In the previous video, we discussed chemical reactions and the fundamental laws that govern them. We also explored the first of these laws, the law of conservation of mass, and understood its significance in explaining chemical reactions. In this video, we will continue our discussion by exploring the remaining fundamental laws and their role in understanding chemical transformations. Let's start with the second law, which is law of definite proportions. It was proposed by Joseph Proust. This law is derived from a question that, does a compound always contain its elements in the same proportion? To understand this in a modern context, consider citric acid. Is the citric acid extracted from a lemon chemically identical to the citric acid synthesized in a laboratory? If the answer is yes, then both samples must contain carbon, hydrogen, and oxygen in exactly the same mass ratio. Back then, Joseph Proust analyzed compounds obtained from different sources and prepared by different methods to answer this question. For example, Proust found that pure water always contains hydrogen and oxygen in the same fixed mass ratio, irrespective of its source. Whether the water is collected from a river, the sea, rain, or prepared in a laboratory, its chemical composition remains identical. Every pure sample of water consists of hydrogen and oxygen combined in a fixed mass ratio of 1:8. This law states that a compound always contains the same elements in the same mass ratio. This suggested that compounds are not random mixtures but have a definite composition of elements. Now, let us move on to the third law, the law of multiple proportions. This law was proposed by Dalton. The law of multiple proportions explains how the masses of two elements are related when they combine. It states that, when two elements combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in simple whole number ratios. Historically, chemists had been trying to understand the formation of different matter from the limited number of 118 elements. It gave rise to a fundamental question. Can the same two elements combine to form more than one compound? If they can, do they combine in any arbitrary proportion, or is there a hidden pattern? In the early 19th century, scientists discovered that carbon and oxygen can combine to form two different compounds such as carbon dioxide and carbon monoxide. So naturally one would expect that matters were continuous and the elements can combine in an arbitrary proportion. In that case, compounds like CO0.5, CO1.5, and C0.10 could exist in principle. But experiments showed a different picture. Chemists found that carbon and oxygen combine only in simple whole number ratios, giving compounds such as CO and CO2, but not arbitrary compositions like CO0.5 or CO1.5. This remarkable observation became the basis of the law of multiple proportions. Let us understand this law with a simple example. Suppose carbon and oxygen form only one compound. You find experimentally that 12 grams of carbon combines with 16 grams of oxygen. So the mass ratio is 12:16, which is 3:4. Now imagine they form another compound. This time you perform an experiment and found 12 grams of carbon combines with 32 grams of oxygen. Now ask yourself an important question. When the mass of carbon remains the same, which is 12 grams, how are the masses of oxygen related in the two compounds? In first compound it is 16 grams, and in second compound it is 32 grams. So the ratio becomes 1:2, which is a whole number ratio. In another reaction, 24 grams of oxygen is combined with 12 grams of carbon. Here, if we compare the mass of oxygen of the third compound with the first, then we will have a ratio of 2:3, which is again a whole number. Even if we compare with the mass of oxygen of the second compound, we will have a whole number ratio of 24:32 or 3:4. Now let's take an hypothetical reaction where 12 grams of carbon combines with 21.5 grams oxygen. If we compare the ratio of mass of oxygen with the first, then it will be 16:21.7, which is not a simple whole number ratio. So this compound does not exist. From these observations, Dalton concluded that whenever two elements combine to form more than one compound, the masses of one element that combine with a fixed mass of the other are always in simple whole number ratios. This statement is known as the law of multiple proportions.